Hey guys, had another question on this Kinetics basic quiz, question number 3, and I thought I'd just spend a couple minutes going through how to solve this. And basically what it is a massive plug and chug type question that becomes a game of units. So this question asks for the initial rate in the equilibrium of substrate A going to product P, and it wants the initial rate in the units of micromolar per second. So this is our ultimate goal. You're given a bunch of constants, which I've listed here on the right, and you were given two equations, and it turns out only one of which solves for rate. So this is the equation we're interested in. And basically, we can take all of the constants that are given to us and plug them in here. The problem is we just have to make sure we end up with micromolar per second. So let's just plug everything in as they are, and we can go from there. So we're solving for rate, and our concentration of A was given to us as 0.001 molar. Our K is listed here. Sorry, and so this our ideal gas constant should actually be joules per mole Kelvin. So our Boltzmann constant K is given to us here. That's 1.381 times 10 to the minus 23rd. And that's in joules per Kelvin. Times T, which is our temperature, was given to us as 300 Kelvin up here. So we've used these two so far, or these three rather. And that's going to be over H, Planck's constant. So that's 6.626 times 10 to the minus 34 joule seconds. So we've used this as well. Now, we can take this and we need to multiply it by exp of negative delta G double dagger, which is our transition states energy over RT. So this exp literally means the same thing as e to the power of. So we're taking e to the power of negative delta G double dagger, e to the power of negative now 30 kilojoules per mole over R, again, our ideal gas constant, 8.3, sorry, I'll clean that up just a touch. 8 point, or not, 8.314 joules per mole Kelvin times our T again, which was 300 Kelvin once again. So if we look at the units that we have in each of these sections, we can clean this up a lot and make our way towards our micromolar per second, our ultimate goal. Micromolar per second is what we want. So we can just basically start to cancel these guys out. Sorry about that. We can cancel these guys out. Just the units so far. So we have a Kelvin here, which is multiplied here. So those Kelvins can cancel out. Our joules can cancel out here. And the power that comes out of this particular section is seconds to the minus 1, reciprocal seconds here. And in the power, we have kilojoules per mole over joules per mole Kelvin. So we want to cancel out these kilojoules, so it actually becomes easiest if we can convert this into joules. So we take rather 30,000 joules per mole, and now we can cancel out joules per mole, and we cancel out joules per mole. We can cancel out Kelvin multiplied by reciprocal Kelvin there, and it turns out our power is actually left unitless, which makes things nice. So overall, we have a total units of reciprocal seconds, and here we're sitting at molar. So we're going to want to convert this to micromolar. And the way to do that is to take this number and multiply it by 10 to the 6. Oops. 10 to the 6. So if we take this number and multiply it by 10 to the 6, we get 1,000 micromolar. So we take 1,000 times all of these crazy constants that are left, and what we get is something that looks like this. It ends up being about 3.74 times 10 to the 10th, which is a massive number. So 3.74 times 10 to the 10th micromolar per second. So again, even if it is a pretty straightforward calculation with most of the information given or all of the information given, it just becomes a game of units to reach the desired answer. All right, good luck.